My name is Pratik. I am a supply chain professional, and recently I have developed a tool that facilitates demand and supply planning for the companies. I wanted to share it with you and know what you feel about it. So, to begin with, I have a file called Marketing Department, which consists of all the critical data that are required for the demand planning. And let me quickly open this. In the top of this file, we have the different regional markets, the geographical markets to which the company sells its products. So we have EMEA, APAC, NORAM, UK, and LATAM. So these are the five regional segments to which the company sells its products. We have the product portfolio mentioned here. It consists of 10 products from product A through product J. And below here we have the sales data for the year 2024. We have the monthly sales mentioned here. So for each of the products in every uh, regional market, the sales in each month is actually displayed here. So below this, we have the monthly forecast for these products in each of the regional markets. The monthly forecasts, which are mentioned here from January 2024 through December 2024. And below this, we have the end of the month back order data. So these are the unfulfilled customer orders at the end of the month. The demand that we could not satisfy at the end of the month are actually mentioned here. These are the relevant data that are required for the demand planning. And let me quickly close this and open the tool now. We have the tool here. I have named it as Amitabha, which means unlimited light, or which means unlimited. When I open the tool, the logo pops up. I have just made it for the aesthetic reasons. It looks nice when we have the logo popping up when the tool is opened. So in the first tab in the MP and S database, we have the information that I previously gave you about the regional markets and product portfolio. Along with that, we have the selling price of the products in different regional markets. We have the products listed here and the marketing segments here, and basically consists of how much of each of these products would cost in different regional markets in euros. So we have these data in the MP and S database. If you go through other tabs, you can either see errors or zeros, which really does not make any sense. So how are we going to make these to make sense? So what we need to do is we have to go to the utilities and insert data, which is basically the marketing department file. We have to go to the folder and click on it, open the marketing department file. So now the data from the marketing department files, as you can see, the sales and demand data have been successfully copied, imported here. So you can see now that we have a graph that is popping out, and also the table which does not have errors or zeros anymore. So let me quickly explain this to you. In the first table, we have the region and product mix, and we have the drop down menus here. So we can select the regional market, the geographical market, whichever we need to analyze, and we can select the product that we want to analyze in that regional market. So we are here in this table, we are analyzing product A, the performance of product A in the region EMEA. So you can see the quantity of sales and the end of the month back order imported from the file in the market from the marketing department file. The tool calculates the total demand and forecasts using the simple exponential smoothing method. And we have only considered the alpha factor. We haven't considered the beta and gamma, which are nothing but the trend factors and the seasonality indices. But I just have used the level indices here. So I have used solver to optimize the alpha value so that we have uh, as minimum error as possible between our forecast and the total demand. And and also we have forecasted the demand for the month of January 2025. So this graph shows you the total demand versus the forecast. The line graph is the forecast, and the columns are the total demands. So in the second table, we have the demand planning at regional levels. It does not consist of any products, but just the regions. So we are just analyzing how the company is performing in each of the geographical markets, irrespective of the products. How much of sales we have in a geographical market, how much we have forecasted, and what is the error, and what in total in units, what is going to be the forecast for January 2025 are all mentioned in this table and represented in a graph adjacent to it. So you can see that for different regional markets, you can change the regional market in the drop-down menu and see how the pattern is between the total demand and the forecast. Okay, and here in the third table, we have the demand planning at product family level. We do not have any regional constraint here. We just see how the different products are performing irrespective of the geographical market, how the products are performing for the company. So we have the total demand irrespective of the regional markets, and we have the total forecast as well. And we have the graph that represents the total demand versus forecast. And we have the forecast for January 2025. So we can change the product and see how each and every product are performing for the company. So once we know what is going to be the forecast for January 2025, and once we have analyzed the previous performance in terms of total demand and the forecast accuracy that we were able to achieve, the next important step is the S&OP planning. For S&OP planning, there is another important data that is critical, that is the stock levels at the supply points or the distribution centers. But we will see that later. Let us first quickly open the S&OP planning template. I got this template from Mr. Kunal Jetwa. He has a very good video template, video explanation of how he has created the template and how it looks. It is simply brilliant, and I have to give the credit to Mr. Kunal Jetwa for this. So in this template, you can see the region products are mentioned in the column A and B, and the demand for them are mentioned for each month here, and the forecast for December 2024 is also mentioned. You can see the total demand and actually the forecast, and you can compare them here. And here is the error between the demand and the forecast, and here is the percentage error, which are indicated with different colors here, which basically shows the magnitude of error in forecasting. So if the error is less, if it is below 33%, then it is symbolized with a green color. If it is somewhat medium between 33% and 66% error, then it is symbolized by yellow color. And if it is high, very high, in fact above 66%, it is represented by the red color. And here we have the forecast data, which is imported from the previous tabs. And this is forecast data is for January 2025. When having the S&OP meetings, if the consensus feels that the forecast is going to be greater than what is mentioned here or what has been analyzed and reviewed previously by the cross-functional teams, it can be changed and revised in this cell for the product A, or in this column for different products. So if the consensus feels that it is going to be higher because we had a new customer onboarded, suppose it can be around 1400, say, then we can just revise it here, and it says updated, and we can give the relevant reason for it. We can choose it as the customer onboarding, or if suppose we say that the product A is not performing as we expect, and the sales forecast is going to be lesser than what we have reviewed and analyzed. And suppose we say that it is going to be 1000, and we can give the reason for that also, slow moving. And once we update this, it is going to be updated for all the tabs. This revised forecast is going to be updated for the inventory control, MPS, and all the tabs. So now I have just removed everything just for the explanation sake. And the second important data that is very important for the S&OP planning is the stock levels in the supply points or the distribution centers. So let me quickly open the inventory control tab. Here you can see different regions and different product families mentioned here. And for each and every region, we have the supply points. For the EMEA region, we have Berlin as the supply point. For the APAC, Bangalore. And for NORAM, we have New York as the supply point. For UK, we have London as the supply point. And for LATAM region, we have Mexico City as the supply point or the distribution center. And here we have the stock levels in each and every supply point. We have the in transit data, that is the stocks that are yet to reach the supply point and are in transit as of now. So we have the data about here, and these data come from the ERP when we integrate this tool with the ERP software. So we can either use API integration for integrating the ERP system with this tool, or we can use Power Query if the ERP monitoring is done using another Excel sheet. Then we can use Power Query as well. Here is the days of stock. That again is given can be taken from the ERP system. If we are using SAP, we know that we can use the T code MMB for knowing how much stock we have in each of the supply points. So next, for the inventory control, we have the minimum stock that we can have as a week's stock, that is 7 days of stock in the supply point. The reorder point is 15 days of stock. The base quantity is going to be 30 days and maximum 45 days. The minimum and maximum are given here because the company does not want to lose money due to either due to stockouts or due to overstocking. So we do not want to increase the the holding cost or the cost due to stockouts. That is why we have the minimum and the maximum quantity that we can have in any supply point. And the reorder point is 15 days of stock. And we have the proximity to the reorder point, which basically means that how near are we to the reorder point. We have 165 units of stock of product A in EMEA, more than the reorder point, and we have 4.5 days of stock more than the reorder point for product A for EMEA. So and you can see the monthly stock demand that is imported from our previous tabs, and also it has been calculated for the daily as the daily demand. And we have the number of open orders, which we consider as 10 days of orders as open orders. Now if the stock levels go down, suppose we have integrated our tool with an ERP system, and the stocks are consumed in the warehouse, are being consumed in the supply points, and the stock level goes down by 180 units, suppose for product A, then you can see that the status has been updated to reorder. And you can see the proximity to the reorder point is also shown here. It is 69 lesser than the reorder points in terms of units, and 1.9 days of stock lesser than the reorder point. And the replenishment quantities is 632 orders in order to bring the stock levels to the base quantity. So indent has been prepared, yes. Indent required is yes, and we have to prepare the indent for that. And also, if we have connected the system to the our tool with integrated our tool with the suppliers or the manufacturing hubs Excel sheet or the ERP system, or if it is integrated with the ERP system, it also reflects to them the status of the stock levels, and they can push the inventory to the supply points when they see the reorder status. And you can see that the proximity is -69 and the reorder point is 563, but the stock is 664. So we have to and you can say that the replenishment is 632. This is because we are not going to replenish to the reorder point. We are replenishing to the base quantity, which is calculated um, based on how much levels of stock would be optimum, so that we do not pay too much for holding cost, or we do not pay for due to the stockouts. So based on that, we have set the base quantity as 30 days of stock, and we replenish 632 to bring the stock level to the base quantity. Now, once we have these data, during S&OP, there is another important data that we have to analyze. That is how each of the geographical market is performing and how each of the products are performing in terms of units of sales and also in terms of revenue. Because our S&OP planning is also tied up with our budgetary goals or financial performance, financial goals. So here we have the table which shows product versus region, and we have the units of products sold in each of the markets. You can see the maximum sales in of products in each in any market. So, and you can see the greatest contributor in terms of sales. So which region is contributing the most for the sales, and which region is contributing the least, and to what percentage of sales do these regions account for, this product accounts for, uh, is also shown here. Sorry, the region accounts for is shown here, and how each of the products are performing in each and every market is also shown, which is the greatest contributor to the sales and which is the least contributor to the sales in any market, and what is the percentage of sales they account for is also shown here. So if I have to explain, product B contributes the greatest. The greatest in the EMEA region. It contributes to 11.9% of the sales in the EMEA region, and product J contributes the least in the EMEA region. It contributes to 3.2 percentage of sales in the EMEA region. Same goes for the EMEA for the regional product impact. So here EMEA is contributing the greatest for product A, which is contributing to about 23.9% sales, and UKI for product A is contributing about 14% of the sales. And we have the total number of units sold, and in total, irrespective of all the regions, which product is contributing the most is also shown, which market is contributing the most is also shown here. So here, with respect to the euros, which particular region is contributing the most for the revenue and which is contributing the least for the revenue is shown here, and to what percentage of sales they are contributing to. And same goes for the products, which product is the greatest contributor in any regional market and which is the least contributor, and to what percentage of sales or to what percentage of revenue do they account for is shown here. And here is the highest market specific revenue and which region is contributing to that, and the least market specific revenue and which region is contributing to the minimum revenue is also shown, and the total revenue is also shown in this particular cell. So this also helps in the S&OP planning for the company. And the next, once we know the inventory levels and the demand forecast, the next important step is we need to calculate the production targets. And the production target is to be calculated for the month of January 2025, and we need to prepare a master production schedule. So here you can see we have a master production schedule. I have automated this. So we have the demand data here imported from the previous tab. So there are four important criteria that I have considered here. One is the aggregate planning. So we cannot exactly produce for the demand, because if there is a demand spike in between the production or during the middle of the month, then we will run out of the stocks. So we always have to maintain that excess inventory or the inventory buffer, so that we can tackle these demand spikes. So we can set the aggregate percentage here, that is how much extra we need to produce. If the demand is perfectly stable, we have no issues, we can choose this to be 0. If the demand volatility is less, then we can select 3% or 5%. If it is more, we can select 10% or 15%. This is the first criteria. Now for now I'll just select it as 10%. Now the second criteria is job changes. Every marketing facility is actually constrained by the number of setups it can have in a day, because setup takes time, and there is cost tied up to it also. We The manufacturing facility is constrained by the number of job changes it can have. So job changes here, it means how many products we can manufacture in a day. Can we manufacture two product families, or three product families, or four product families? So for now, I will set it to be two product families, suppose. Okay. Now I just have to click on schedule production, and production schedule has been created. And the fourth condition I forgot to mention, sorry, the third condition is that during the weekends we can have only one product to be produced, because there is no white collar workers to authorize production. So we just have one product. And the fourth constraint is that the daily product production target should be almost balanced, because if we have just 10 products produced on one day and 500 products produced the next day, it will result in underutilization or overutilization of the capacities. So they have to be properly balanced. We can have little bit of variations, it's not a problem, but it should be balanced. Here you can see the total produced. We have 10% extra produced than the demand, and you can see the extra in terms of units here. And I have just made one more column for error check. If it is producing lesser than 10% or more than 10%, this column shows that it is going out of the proportion. So here is the total number of products produced in the month of to be produced in the month of January 2025. The next important data is the bill of materials. Bill of material basically tells you about how many raw materials are required, and what type of raw materials are required, and in what quantities. So for product A, you can see that we need two units of component 1, 5 each, and three components of component 6, and one unit of component 2, 3, 8, 9, and 10. So it shows how much of raw materials are required for producing each of the products. So suppose if I want to produce a particular number of a product, suppose I need to produce 615 units of, say, product C, then you see the how many components are required, or how many units of different components are required for producing product C. So you can change this as well. You can um, select product G, and suppose I need to produce 149,852 units of product G. Then it shows how many units of each of the components are required. Here is the combination, that is the mix of different products. Suppose we need to know how many components are required to produce a combination of products. So suppose then we can just input the numbers here. So suppose we need to produce 165 units of product A, 147 units of product B, 1509 units of product H. So it will show in total how many units of each of the components are required for their production. Okay, now uh, the next important aspect is the material requirement planning. Now we have the production schedules, and we need to plan the material requirement, the raw material requirement for these for the production. We have already seen the bill of materials data. So we know that we need components 1 through component 10 for producing the products A through J. So if we go to the MRP sheet, you can see the products listed here and the product volumes that comes from the MPS sheet here. You can see here, it's the same. Now the components are listed in the column C, and we have the starting inventory that usually comes from the ERP system. Here, since we haven't integrated this with the ERP system, I have just chosen some random numbers for this. Here we have the minimum quantity, reorder quantity, base quantity, and the maximum quantity. Reorder point, as said previously, the reorder point is 15 days of stock, minimum quantity is 7 days of stock, base quantity months of stock, and maximum is 45 days of stock. So here we have the material consumption metrics, and we can choose the lead time. I'll come to the lead time later, and let me quickly show you this. If we click on the monitor inventory, you can see we have the starting inventory here in the beginning at the beginning of the 1st January 2025. We have the starting inventory, and as and when the day progresses and the production takes place, the inventory levels of the raw material keeps on diminishing. And here you can see that it is 38,884. The starting inventory is 38,824. And during uh, the production on 7th January, it will go below the reorder point, which is 37,982. And then the raw materials are replenished to the base quantity. So here you can see on the next day, we have the raw materials replenished to the base quantity. And again, the inventory keeps on diminishing till 23rd. Again, it goes below the reorder point on 23rd and replenished the next day. If say the supplier takes more time to replenish the raw materials, we can set the lead time here. We can set it to 1, 2, or 3 days, and accordingly the replenishment will delay. Here the reorder point is hit on 7th Jan. So if I choose the lead time as 2 days, then the replenishment day will be 9th of Jan, and it will not be 8th of Jan. Okay, so here you can also see that the replenish dates are mentioned for each of the components, and the replenishment quantities are also given. So on 7th January 2025, 39,672 units of component 1 are replenished, and on 23rd, 38,576 units of component 1 are replenished. So this is valid for all other components as well, you can see here. And here is the ending inventory at the end of the month January 2025. What will be the status of the inventory, the raw material inventory, or the ending inventory of the raw materials of each of the components is mentioned here. So in the graph you can see that the inventory is reducing, and then it is replenished, and again it diminishes as and when consumed, and reduces. So once we have analyzed all this, all aspects of beginning from demand forecasting to material requirement planning for our raw materials, we can generate a report with all the critical touch points or all the critical information. We just have to click on the summary report here, and you can see that our tool is generating a report with all critical information. So we can keep this report and discuss with the higher management and decide what needs to be done. So you can see that some of the information are omitted. We do not have the data about previous sales and all. We just have the December here, and we have the financial performance here, and here also we do not have the daily demand data or open orders or anything. We just have the reorder point, base quantities, and the status of the inventory, and how close we are to the reorder point and indent requirement and everything. Here is the MPS data, the total demand, the total produced, and the extra inventory that we have produced. So we have the information, all the relevant information here, even about the about the material requirement planning. We have all the information generated in this report. So we can use this report to discuss with the cross-functional teams or with the higher management. So this is how the tool looks, and if we want to reset the tool, all we need to do is delete the report here in this sheet, the MRP sheet, clear the data, go to the MPS tab, clear the data here as well, and go to the marketing department file and just remove it, and you can see that the tool has been reset. Okay, so this is how the tool looks. Please let me know what you think about it. Your feedback is very important for me to further develop this tool or to work on other tools, and also improve myself in terms of concepts of supply chain and logistics. So please let me know what you think about this tool. Thank you so much for your time, and I wish you all a very good day. Bye.